Hi folks, so the question we have in front of us here today is the question from 2019 Junior Cert Higher Level paper, question 2. It covers the area of rotations and also other elements then on maybe a little bit on polygons and circles in contact. So we'll start off by reading the question, and it says the elevation, end view and a 3D graphic of a sign for a coffee shop are shown. The sign includes a semi-octagon A, B, C, D, E, F. Okay, so we can see that down here, A to B to C to D to E to F. So basically it's a half octagon, so a semi-octagon. The line EG is a tangent from E. So it's, you can see here we've obviously got a semicircle as well, where you'd obviously have kind of the handle of the cup. And the line EG is a tangent, so we're going to have to get a tangent to a circle there. And then it says the curve JKL is a circular arc. So we've got a curve down here, J to K to L, and that is an arc. It does not give us the radius of it, so we have to find the center. Obviously the center is going to be somewhere down along that kind of center line there. So what we're actually going to probably have to do there is find chords and bisect the chords to give us the center. And then it also says the curve QRS is concentric with JKL, which basically what that means, concentric means they share the same center. Okay, and we can see the distance from K to R is 10 millimeters away. Okay, it says so, draw the given elevation and end view. Okay, so we can see the elevation here, and then the end view we would see it as a line as you look in from the side, obviously because the sign we only see it as an edge view. And it also says the sign is rotated through 45 degrees, so it's like the wind has come from behind it and blown it to an angle of 45 degrees, about point O, so that's its hinge up there, as shown by the broken line in the end view. And then it says project the plan to show the sign in the rotated position. So basically what we're going to do is complete the elevation, project our points across, rotate it up to the 45 degree angle, and then project them down to our plan using normal orthographic rules. Okay, so we'll start on that there now. A little bit here on the octagon that will come into effect when we start on that. And but I'll start off by essentially doing the outline of the overall sign, and then we'll get into the actual teacup portion. Okay, so I'll start off with the outline of it, and then doing this section inside in here, the QRS curve, and then joining Q to S as well, and obviously the JKL curve, and then we'll finish it off by doing the teacup. Okay. Right guys, so what we're going to do is we're going to start off by drawing the overall outline, okay, and we know from our measurements we can see that it's 120 millimeters long. So I've drawn an XY line roughly down halfway down my page. I know the overall height of it is also 120, so I've just kind of made sure I have enough space from the top of the page, and I have to kind of estimate how much space I'm going to need then for my plan. So I'm going to mark there 120 millimeters along my XY line, so 120. And I'm going to mark for my end view, which is just a line, I'm going to mark a distance of 10 millimeters over. And the overall height of it is 120 millimeters. So project up a line, mark the 120. I'm just going to mark a box that it's all going to fit inside. Starting off, project the line up, and then the overall height of it is about there. So that's the area that it's going to fit inside. These are all construction lines, okay. I'll start off by putting in my overall heights then. So measuring up, the first one is up 10. Then I think it goes 30, 10 plus 30 is 40, so I'm sorry, it's 30 into it, yeah. Alright, so it's 30 there, and then it's 80. So 3 plus 8 is 11, and then we have 10 left over at the top. So just on that, just making sure I'm doing that correctly. Project this line across, because that will give me the points J and L. And then I've got this line here at the top. And I also need a center line running down through it. So half of 120 is 60. So there's my 60. And project that center line up and down. Long line, short line, long line, short line. Okay, center line there. And what we want to do now is just use a little bit of labels. Okay, so I have the points J here, I have K here, and I've also got L. And I also need to find the point R as well, which is up 10 millimeters from K. So right there, that point right there is R. I'll put R just directly underneath it. Okay, so start off by having in my outlines. Actually, I'll mark in this as well. I know it says 60 wide for the teacup, so I'll mark 30 either side of the center line. Okay, just to have those ready. And what I'll do is I'll start by having in some of my detail now. So these are my vertical lines. This is kind of where the signpost hangs onto. Okay, now I'll put in my horizontal lines. Okay, and what we need now is the curve JKL. Okay, so anytime you're dealing with a circle, okay, and we know we have a curve there joining from J to K to L, what we actually need to do is we need to find the center. Okay, now by looking at the question we can tell that obviously the center is somewhere along this line here, but we need to find it. So the way to do that is by connecting up a chord. Okay, and if you connect any 2 points that are on the circumference of the circle, okay, by creating a chord like this, so that line there is technically a chord of a circle or of an arc that we need. By bisecting that chord, what we can actually find then is the center. Okay, and we know the center line is actually, the center point is somewhere along this center line here. Okay, if you didn't have the center line, you would just connect K to J as well, and you'd have two chords, and you'd bisect both chords to find the center and where those bisectors cross. But we know where our bisector of the line KL, which is a chord, where that cuts through the center line will give me the center, okay, of the arc that I need. So bisect that. Distance greater than halfway, both sides. Keep the same distance on your compass. Okay, and then with this point right here, and this one here, make sure I have the exact points. Okay, so that's my bisected chord. You can see now it's after going through the center point up here. And what I'm going to do now is complete my arc, JKL. So, using this as the center, I'm just going to check that it goes through all the points. So, mark it out to J. So there's my J. Does it go through K? Yes, it does. Does it go to L? Yes, it does. So, I'm happy with that. Okay, so there we have it. There's the arc JKL. Now we also have another arc which is called QRS, which it says is concentric with the arc, okay, JKL. So sharing the same center, I can take my distance then with my compass and my pencil point down to R and swing an arc that is concentric. And we know then that Q and S are on the same line connecting J to L. So just draw that in there now. So there we have it, and now we have found Q and S as well. Okay, so that's kind of the main outline of the sign there, and obviously the two circle parts figured out just by bisecting one of those chords to find our center. Okay, they're the kind of tricky things that throw at you in these questions. Now the next part of the question, what we have to do is we have to complete the teacup. And we know the teacup is as wide as kind of the sign parts up here that are connecting the sign obviously to whatever it's hinging off of. So while I'm at it, I am going to project down that line there and this line here, because that's the area that the signpost is contained within. And then from there I have actually a little bit of measurements to do. So from the top of my page it says it is down 10 and then down 40. So I'll mark down 10 just from 14, so down 10 and then another 40, should be to here, just to have those in. That'll actually give me the top half of the teacup, which I'm actually going to heavy in. So this portion of the teacup here. And I know I've obviously got the handle connected on over here, so that distance is 40. So my radius then, I'll actually mark it already, is going to be down 20 millimeters. So from 14 down to 10, mark down 20. So right there, at that point, that's my center point, okay, for the semicircle on this side. And now what I have to do is, from this point right here, this technically is A. And I've also found F on the opposite side, which is right here, right there. So what I need to do is I need to complete the semi-octagon, connecting A to B to C somewhere down here to D to E over here to F, okay? And to be able to do that, I'm just going to actually use over here just for a little bit of explanation purposes, okay? So what I'm actually going to do now is, essentially, in any circle, you can draw an octagon inside it or any polygon inside the circle, but technically you can also do it with the circle outside it, okay, or contained within, okay? So inside, I'm going to basically be drawing an octagon that consumes this circle here, okay? I've drawn a random circle, but essentially I'm going to be drawing in an octagon. Now we know an octagon is an 8-sided figure, and anytime we work with polygons, usually what you do is you divide the number of sides, okay, which is 8, into 360 degrees, which is obviously the angle within a circle. So 360 divided by 8, we know equals 45. So that's kind of our magic angle there. The 45 degrees is for the exterior angle of the octagon. So 4 sides I know are going to be where the axes are, okay? So if you imagine here, and I'll use a light line here first. So from this point here, I would have a vertical line, the exact same on the opposite side. And then for the base, I should say, at the bottom point here, I would have a horizontal line and a horizontal line, okay? And you can see here it's kind of making almost a square. Now, technically, those lines there are all tangential, okay? And they all meet at 90 degrees to the axis. Now we know that an octagon, okay, is at 45 degrees. So from these kind of spaces within here, okay, I'm actually going to create more tangents that are at 45 degrees. So I've got one here, I've got one here, here, and finally here. And you can actually see the octagon take shape now, okay? But what's important to note is, as I said, these lines are kind of like our tangent lines, okay? And at every one of them, okay, they were perpendicular. So what we could do from the center, okay, by projecting from the center 45 degrees down to where the circle is, we can actually find that point of contact right there, okay? And what we know for the question over here, A, B, C, D, E, F, if we treated this as A, this point here is F, well, we've now found B, which is there, C is here, D is here, E is here, because we only need the semi-octagon. We only need half of it, okay, to complete our little teacup. So that's the bit we need there. Just heavy that in. This is just for explanation purposes. That bit there, and finally this bit here, okay, A, B, C, D, E, F, okay. But what's important to note is that the center of the circle that was contained within that octagon, you can project down at an angle of 45 degrees to find the point of contact of where we can actually get the edge BC, okay. So that's going to be very, very helpful for us completing it over here, because we already know that the line AF has the center. So over here, this point right here is the center of a circle that is contained within. Okay, so that's what we're going to do. So using our compass, you could draw in a semicircle in this case, from A to F. Just make sure I got that in accurately. So a semicircle from A to F. Okay, like that. And what we do then is we can, from the center point, project down at an angle of 45 degrees. And where that cuts the circle right there is a point of contact for the angle, or sorry, the edge of my octagon, BC. So right there is my edge. So now I have found B and C. So I can do the exact same to the opposite side. Found the point of contact, which is right here. and then project up at 45 degrees. Now, technically we know it's a tangent, so we could have just worked it out that way and that would have been fine, but it's always helpful just to prove exactly how you found it as well. Okay, just tell the examiner you know what you're doing. Okay, so I connect up that edge and finally connect up this edge here. So now we have A, B, C, D, E and F. Okay, and that's the semi-octagon part of the question completed there. Now what we actually have to move on to is the handle over here. So by using this as my center point and my radius to F, I'm going to draw in my semicircle. There we have the semicircle, and I know I have a tangent connecting here. Now, very, very easy. If you're rushing an exam, you just assume you'd connect up like that, and that is the answer right there like that. But it's important to note that we have to prove that line. Okay, so anytime you're actually doing one of these, okay, connecting up a tangent to a circle, you have a point outside the circle in this case, which is E. Okay, you join the points to the center and you bisect that, and where that bisect point goes through, we're going to swing another arc, okay, another semicircle. So we've already got E connected to the center point, so I actually have to bisect that right there. So pick a distance from E to the center point, distance greater than halfway. And since this line is actually perfectly vertical, I can use my T-square. That's working out fine, and what we have found right there is our center point, right there. And what we're going to do is from there to E, from there to E, like this. I'm going to take that distance, I'm going to swing an arc, and where that arc cuts through the original semicircle right there, that there is my point of contact for a tangent, POC, sometimes you write it. So from E, I can connect that there, and now I've proved that tangent, okay? So I know I'm happy with that. So at this point now, it's just simply a case then of finally having in that detail there. Let's get that in. There's our lovely handle on the teacup. So that there, guys, is the elevation, okay? A little bit in that, in the octagon part of it, and the handle part of it here, and obviously then we had the circles construction here, obviously using a cord, okay? So there's a little bit in that. Now at this point, what we're going to do is we're going to start off with the rotation part of the question. So first of all, I'm going to complete my end elevation over here, which we would see as a line. So I'll project that over, and I think it goes up to about here. So that will be the edge view of the sign. And we know top of it there, we've called it O. Okay, and they've already told us in the question that the sign is blown to an angle of 45 degrees. Okay, may have to project this out a touch further, we'll soon see. So when the sign has been projected, or sorry, blown to an angle of 45 degrees, about O, that's as far as the sign goes out to there. So my Y probably needs to come out a little bit further. And what I'm going to do now is put in the position of the sign when it has been blown to 45 degrees. Okay, so essentially it's like the wind has come along and blown from the back of the sign and has moved it, okay, and it's blown it at an angle of 45 degrees now. Okay, so what we have to do now is we have to find the new position of our plan view. So our plan view, we know, is directly underneath the elevation. So we'll project this down, from the corner of the elevation closest to the end elevation, project a line at 45 degrees, and then check this down, and then finally this point here, because it's as if we were looking down on it in this direction now, as it's been blown to an angle of 45 degrees. So we're going to kind of get a squished version of this. So there we have it, and at that point right there, project it across, and this one here. So that kind of rectangle that we have there, okay, is where our plan view is now going to fit with inside. Okay, so what I'm actually going to do is I'm going to project across. I'm going to start off by doing once again all the detail before the teacup on the inside, and also including the curve JKL and QRS, and then I'll get onto the teacup part. So first of all, for the curve, what I'm actually going to do is I'm going to take a couple of cuts. Okay, so I'll start with the curve JKL. I'm going to take a cut there and a cut there. Just pick the points right here and right here. So that'll actually give me 2 points once I project it across, because it also gives me a point over here. So project them to my end view, and then remember we have to rotate it. Okay, so that gives me a point here, here, them two there, 1 and 2, and then it also gives me one here and here. Okay, so that's in addition already to J, K and L. Okay, and what I'm going to do, oh yeah, J, K and L there as well. So using those, and O is my rotation point, I'm going to rotate them until they're in their new position on the 45-degree angle. Okay, and also this guy up here. So there we have it. Just rotate it across that height as well. So rotate that up, and where every one of them hits the 45-degree line, project it down. So I can transfer my width across here, here, and here, and finally then project them across. So it's kind of a simple point location now. Okay, so I'll also project down this guy here. So he'll come down as far as there. There. So I'm just putting in the sign. So this edge up here, okay, it was at this height, follow it down, bring it across, so that's this line here. That can be heavied in the whole way. I know I've got another line here that's heavy across, so follow it as it rotates, follow it down, so that line there is also heavy the whole way. The two bits connecting them, here and here, are just directly below it, so they're here and here. So as you can see already, comparing this bit here to this bit up here, we can see that this one is a good bit shorter. Okay, now we know it comes straight down as far as L and J. So J and L are, as we project across, they come across to here, over, down and across. So they'll come to here and here. So there's our J and there's our L. So I can heavy in straight down as far as them. While I'm at it, I'm going to find my K, which is directly on the bottom. So as K went across, I'll rotate it up. So there's our K. And finally, what we have to find then is this point, this point, this point, and this point, which are in between. Okay, so first of all, I'll start off by projecting them straight down from our elevation. So it's right here. So go to there. And where they are in my end elevation, now I have to also bring them down. So project this across was this one, which was there. So that'll give me a point here and here. And it's the same obviously then just by working it out, process of elimination, we know it's this one. That'll give me 2 further points here and here. Okay, so as you can see, this is our curve then, JK to L. So I'm quickly going to sketch that in, so I'll speed up the video. Okay, so there you can see we have the curve JK to L, okay. When obviously it has been blown to an angle of 45 degrees, we couldn't put that in with the compass, we have to sketch it. So now we actually have to get the curve Q or an S as well. So we're going to do the same process there as well. So first of all, I'll just find Q and S straight away by projecting down. I know they're already on the line connecting J to L. So just project them down and find them first of all. So Q to S will be from here to here. Okay, and what I need to do also is find points along this as well. I need to find R as well. So I'll project R over to my end elevation, and then where it hits here, rotate it up. But I'm also going to find 2 more points in between. So I'm going to pick a point here and about here. So there and there, kind of like the same with the last process that we did. And once again, that will give me a point here and here also. Okay, so just make sure and identify them. So usually you can use labeling as well. It'll probably help you. But rather, obviously, I've got quite a good bit of labels in here already. I'm just going to try and keep it neat and tidy and follow it as a map. So from O, rotate it up to the 45-degree line. And then finally R as well. Okay, and I'll start off with R. I know it's this one. Project it down to the 45-degree line. Project it across. So there's my R right there. And what I want to do now is I want to find this point and this point. So put it down there somewhere. And likewise with this one and this one. Okay, so starting off with this one and this one, because they're at the same height, where they come across, where they rotate up top. So from there, project it down, which is the 45-degree line, project it across. So there you have it, point right there, and then also point right here, just looking at it up here. Okay, so follow it down, you can see we've obviously our point here. Okay, so that's the first two. Then the next two then are this point, so follow it across up here. So this is the guy I have to bring down. It's right there. And where it hits here, project it across. So there's a bit of work in that there. That's going to give me 2 further points. Just make sure I have the one again. So this is where you can get a bit confused here. So following it there, hits here. It's this guy. This guy, so it's at this height. So that's important to note there. That gives me a point here and here. Okay, so there's my points. Once again, sketching the curve, so I'll speed up the video. Okay, there we have it, guys. That is the two the 2 parts of the curve done at the base. Now what we're going to do is we're going to work on the teacup, okay? And once again, we're going to leave the handle till the very, very end, okay? So on the teacup, I've obviously got the height of it here, so I'll project that across. Okay, the line A to F, which is here. Okay, I'll also connect B and E because they'll be in line with each other. And C and D are already projected across because they're on the line connecting J to L. Okay, so to find C and D, I could actually just project them straight down first of all. Just to have that done. So there's my C and my D. And now what I have to do is rotate the overall height of the teacup, which is there. I have to rotate where A to F was, and then also B and E. So you can see kind of we're working through it. So starting off with the height of it, which is along this edge here. Check that down. Project it across. So I know it comes over as far as, oh, comes over a little bit further. I didn't project down my lines fully yet, because they're in line with this. So there we have it. Check them down. So I can put in the overall height of it there. There we have that. Same here, it comes down as far as the B and E, which is this one. Actually didn't need the A and F, as it turns out. Okay, so same thing. and then finally that connects up there, this connects up here. So I've found, sorry, that's B, C, D, E, and if I wanted to find A and F, it's not essential. If I wanted to find them, it's very simple, just project that down, project it across, and there was our A, and there was our F. Okay, now the last bit is we have to complete the handle inside here. So what we're going to do is we're going to use normal method. We're going to split up our semicircle up here in the elevation into a couple of points. Usually use 30, 60 degrees through the center. So 30 through the center this way. 30, I'm just thinking, yeah, I'll use it there. And obviously we're going to use the point of contact as a point as well. And a point up here. So technically I have this point already found, which is here. We've already got E, so we're going to use the point of contact. So we're going to use the point of contact, we're going to use the point here where the 30 degree line cuts through. We're going to use this point, and this point. So we have to actually locate, it's going to be 1, 2, 3, 4, and finally 5. So we're going to locate, you can see them here, about 5 points there. So every one of them, take it in stages. Every one of these now is on the curve of the handle. So I'm going to project up this one, this one, this one, 2 more, this one, and this one. So as you can see there, I've obviously got 1, 2, 3, 4, 5. 5 lines to project down to my plan view. And these are the widths, so projecting those across. There's 1, 2, 3, 4, and finally 5. Okay, and that's going to help us. So the first one I'm going to start off with is the point of contact, which we know connects to E, so it's somewhere down along there. And I know the point of contact one is this one. So just following that across, follow it here, comes down, so it's the lowest one. So that gives me a point in there. That's that one right there, and that one actually connects up straight. It's just a straight edge because it's a tangent. And what I'm going to do now is get the rest of the points on the curve. So the next one after the point of contact was this guy, so I'll project him down. He's going to be quite close to it. It's on a line there already. So I'm working my way back up. So there's that one. Then the next one is this guy on the outside, which is going to be my center one. So that helps me find the point there. The next one is at 30 degrees, so it's on the same line that I got this one on. Just to prove it, yep. They should connect up, and they do. So just working my way back up. So it's on that one. And then finally, final one is this guy up here. And last which we haven't projected yet, which is here. Project him across. And there we have it. That's our other point. Just make sure, yeah. So at this point, once again, I'm going to quickly speed up the video while I keep sketching the curve. Right guys, there you have it. That is the exam question completed from the 2019 Junior Cert paper. A little bit in that. As you can see, obviously completing the elevation would have been the main problem at the start of the question, and then after that it's actually simple orthographic, okay? But you can see here it can get quite confusing. Now obviously I'm using pens, okay? Red pens are my construction lines, dark pens obviously are my finishing lines. But it can get quite confusing obviously because you have lots of lines here. So my advice to you there is probably use a little bit of labels, especially on maybe the curved parts here, okay? And obviously then if you are using, when you're using pencil, 2H pencil, obviously if you're light lines, okay, and obviously just going heavier then on the dark side of things. But once again guys, that's the question complete there. I hope you found that helpful.